Creo Parametric 7.0 introduces the new extension of Creo Easy Tolerance Analysis, which is powered by Sigmetrics. Creo Easy Tolerance Analysis is the new app for creating and managing multiple one-dimensional tolerance stack-up analysis. In this example, I will be investigating a dedicated gap for this motor's bearing washer, so that the designer can be sure that the washer gap actually meets the acceptance variation range. After defining the area of concern for the stack-up analysis, you will get all the paths that are found for the stack-up that are based on the existing assembly constraints. In this case, I can see that the found path is suitable and I can immediately get my stack-up created in the stack-up table. All the components and annotations that are contributing to my stack-up are listed in this table. Annotations that are already existing in the components are marked with this chain icon, which means that they have associativity and their tolerance value can be updated seamlessly. My next step is to define the objective of the stack-up analysis. For my example, I am choosing a tolerance of ±2 inch as my objective for the gap. At the bottom of the dialog, I can see a visual presentation for the results of the analysis. The default is set to be worst case analysis, but I can change it to root sum of squares, or RSS, CPK, or any other common statistical metrics. I have decided to set CPK goal of 1.3, which can be suitable for similar cases, but I am still not meeting the requirements and I need to modify the stack-up tolerances in order to meet the criteria. I can click the Contribution tab and observe which annotations are influencing the most. Based on this information, I can decide which tolerances I will be tightening in order to achieve my analysis goals. After I'm done, I can rearrange the stack-up annotations in the graphics area, save the view orientation for the favor of the report, and also decide if I want to create a model tree feature for my stack-up that will be populated with the respective analysis parameters. Now let's say that I have another request for a stack-up analysis. This time, I need to investigate the distance between the rotor and the stator of this motor. At first, I am getting an axial distance, but I will be changing this later on. This time, there are no assembly constraint paths that I can use, so I will be creating them manually. I start by selecting all the stack-up components according to their interface sequence. Next, I will be picking the interface surfaces, and while doing so, Creo Easy Tolerance Analysis will help me to easily define my stack-up by showing only the current and next components visible on screen and by changing their transparency. After the stack-up is created, I will update its name, change the direction to show radial distance, and will define the objective to be greater than 0. In many cases, one-dimensional stack-up might be enough. However, in more complex cases, like this one, Creo Easy Tolerance Analysis will flag when it would be advised to perform more advanced analysis due to potential 3D variation effects. Finally, when my stackups are defined, I can quickly generate a detailed HTML report that contains all the details for the analysis, contribution graphs, and a summary that I can conveniently send to my colleagues.